So welcome back. Hello everyone. So today I am going to show you how to perform a logistic regression based classification in Raspberry Pi Pico that is running a MicroPython. So as you know that in MicroPython there is no such inbuilt NumPy like package, and I already mentioned in my previous video in linear regression. So it's quite difficult to develop the basic machine learning modules such as linear regression or logistic regression without the NumPy array. So in this work, I have developed all these NumPy-like features which is required to perform this logistic regression using Scratch, that is by using that native Python list. So let's start. So now I'm going to classify. Basically, it is a binary classification problem. So the person who is having diabetes or not, we are going to classify it. And the dataset is taken from Kaggle. It is Indian diabetes dataset. So that dataset link is given in the video description. So you can download the CSV file from there. So let us take a look at the dataset. Currently, we are working with the data set. So that looks like this one. As you can see, there is a column. Features are pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and the outcome. So that is the Y column. So 1 means the person having diabetes and 0 means no diabetes. So first, that model is developed on the scikit-learn inbuilt logistic regression function just to verify the accuracy and the correctness of our Scratch model. So let's start. Let us see. So the pandas library is loaded to read the data from CSV file. So these are first few columns. Okay, and then scikit-learn is used and the scaling is done. Okay, then that test train speed, that is same as any other machine learning algorithm. So you can put one test size. So here I put some test size 0.13. So this is just to match the number of test data we are using in MicroPython. Okay, the model is developed here, the scikit-learn, and there is a confusion matrix. Okay, so around 100 or 110 data is classified, and we got a confusion matrix like that. And the same thing is developed on MicroPython. Okay, so that here I write a package. So all that functions that is required for logistic regression is inside this folder. Okay, that code you will get from the link mentioned in the description. So the purpose of this function is to read the data from CSV file. Then the same as your normalization of data, which is done by the standard scaler in scikit-learn. So basically the normalization is performed using the mean and standard deviation of the data. And then the test train split is there. So I'm just taking some, the ratio. So why I have taken this, so let me tell. The main drawback of that Raspberry Pi Pico is it is having only 1 MB of RAM, and some of the RAM is already occupied by running the OS itself. So if you load the whole data set, the original data set here, okay, that means it is having 8 feature column and total 769 rows. So it will require a lot of RAM. Okay, so that hardware doesn't have that much amount of RAM. So we cannot we cannot train the model directly from here. Okay, so what we can do, there are 2 ways. So first, you can reduce the size of CSV file. So I have tested that if you are having 100 number of data, means 100 row in a CSV file, it is working, and it can perform the training also here. So you can check it here. So I will show you. So here by changing this parameter, you can go for the training. So let here the train test split size, I am taking around 0.9. That means the 90% data will be used for training purpose and 10% data will be used for testing purpose. And then I can call that model. So this one is the training and X value and Y value, and this is learning rate and number of iterations. I'm setting it to 1000. Then I can predict the data and I can go for the classification report and it will print some accuracy value and confusion matrix. Okay. So let's do that job first, then we can move to the next. So it will take some time first because it is a small microcontroller. So you cannot expect the performance just like your PC. Now you can see the number of epoch, that means the iteration is going on, and at the same time it will print the loss. Okay. So if you take more data, so here I am taking around 100 or 110 number of row. So if you take more data, so it will report some memory error because there is not enough RAM in the Raspberry Pi Pico to train the model. So as you know that in case of any machine learning model, if you have more number of training data, the model will be accurate. But unfortunately, we do not have that much amount of data. It means we cannot accommodate that much amount of data here to train the model. So directly from Raspberry Pi Pico hardware. So we have some alternate options. So I will tell you, so let's see that first. So now the training is going on. So it will run for 1000 iteration and just wait. Yeah, 800. And you can see the training loss. Gradually the loss value decreases. Yeah. So here you can see the training accuracy around 71%. So the confusion matrix is plotted. So if you add all these values, so you will get that total number of data used here. So 40 plus 20, 60, 70, 80. So around 90, total 90 data is used here. Okay. So this one is the performance. Okay. And similarly, this model, you can go for testing of this model. So as I already mentioned that since we have less amount of data, we cannot load all the data in the memory due to the deficiency of memory, RAM. So there is another one option. The option is you can run the whole model in any, that Python software means machine learning platform. You can run it on Google Colab or PyCharm. Okay, so I will comment out these lines. So I'm no longer using the training feature. So what I can do, so here, after training the model, so I can fetch the weight and bias of that logistic regression. Since we are using 8 features, so you can see the column. So 1, 2, 3, 4, 5, 6, 7, and 8. So 8 X values, you can say column, and 1 Y column, okay, the target. So 8 features are there. So there will be total 8 value of weight. So as you can see, the weight is fetched here 1, 2, 3, 4, 5, 6, 7, 8. So you can print the weight by using this command. Okay, similarly, you can fetch the bias value by using this. So I can copy this weight and bias from here to this platform. So you can see I just copied the weight and bias value from there. Okay, so maybe this W and B value will be different because I've changed the value here or something. Okay, so the process, I'm just telling the general process. You just copy the weight and bias value from there, make sure that it is in form of Python list. Okay, then you can call the prediction. Okay, so that inbuilt function is already present. Okay, so I can call that. Oh, sorry, I'm not using this one. Yeah, this. So weight and bias values are copied. So 0.37, 1.06, 0.25, as you can see. Yeah, this one is just copied. Okay. So windows are open. Yeah, the bias value is open. Then I'm calling that classification module. Okay, and this along with this externally supplied W and B values, and we can go for the classification. So let's go for that. Okay. So instead of using that inbuilt training, so I can directly go for this. So what I can do, I can reduce this value to some value, let 0.01. So I've supplied 100 column there. Okay, so I'm using almost all. So you cannot set this. Actually, this is the training size. Okay, so I'm using very few number of training size, the maximum data used for testing purpose, and I'm not going for training actually here now. Okay, so if you set this parameter to 0, actually, so it will report an error. So in this function, will report an error. Okay, this function. So we cannot set it to 0. At least few training data should be there. Okay. So now if I run this, so let us see. Yeah, there is a confusion matrix. So you can see that 52, 20, 16, and 11. So it is, these figures are almost same as this. Yeah. So here it is 21, here it is 64, it is 10, it is 5. Maybe there is a mismatch in the number of test data. Okay, so here we are using maybe around 120. In MicroPython, I'm using around 100 or 110. So there is a mismatch. So anyways, the results are post. So we have two different techniques to train the model. But you know that due to the RAM shortage, you cannot perform a good training in MicroPython. So second option is I think it's the best option. So you perform training, you fetch the weight value and bias value, and you just paste it in the MicroPython environment in thonny. Here, you call the prediction, and you can predict it. So in real cases, when you are running this along with some hardware, so you can collect the training data from hardware, that may be from accelerometer or something. You can pre-process the data. You can perform normalization, and you can train the model. Then you collect what is the weight value and bias value, supply the data here, okay, for testing purpose. So now you can run this model. Okay, so there will not be any RAM deficiency here because we are using a less number of data for testing purpose, and it will run. Thank you for watching. So if you have any suggestion, you can put it in the comment box. And I know this is it's not optimized for speed. There are a lot of bugs and all these things are present, but still the performance of this basic model is much better in this MicroPython environment. So it is working fine. So you can use it in any project development purpose, which uses that, the logistic regression. Thank you.